This is Niels Bohr, a Danish physicist working in the Rutherford Laboratory in 1913, when he proposed a quantum model for the hydrogen atom that seemed to answer the question that many scientists had before. Bohr's model also correctly predicted the frequencies of the lines in hydrogen's atomic emission spectrum. He proposed that the hydrogen atom has only certain allowable energy states. The lowest allowable energy state of an atom is called its ground state, when an atom gains energy and it is supposed to be in an excited state. Bohr also related the hydrogen atom's energy states to the electron within the atom. He said that the electron in a hydrogen atom moves around in the nucleus in only certain allowed circular orbits. This diagram shows an atom that has one electron. In its ground state, the electron is associated with the lowest energy level. When the atom is in the excited state, the electron is associated with the higher energy level. To help his calculations, he assigned a number n, called the quantum number, to each orbit. Along with that, he calculated the radius of each orbit. Bohr said that the hydrogen atom is in the ground state, also called the first energy level, when its single electron is the n equals 1 orbit. In the ground state, the atom does not radiate energy. When the energy is added from an outside source, the electron moves to a higher energy orbit, such as n equals 2, as shown in the diagram. When an electron drops from a higher energy orbit to a lower energy orbit, a photon is emitted. Only certain energy levels are allowed. The energy levels are similar to the rungs of a ladder, for example, as seen in our textbook. The 4 visible lines correspond to the electrons dropping from a higher n to the orbit n equals 2. As n increases, the hydrogen atom's energy levels are closer to each other. But the hydrogen atom's energy levels are not evenly spaced at all. Bohr's model was really well explained to hydrogen's observed spectral lines, but didn't really explain the spectrum of any other element involved. Later experiments in the future demonstrated that Bohr's model was fundamentally incorrect. Scientists formulated new and innovative explanations of how electrons are arranged in atoms, which later fixed energy levels of Bohr's model. His name is Louis de Broglie. He was thinking that Bohr's quantized electron orbits had characteristics similar to those of waves, so he decided to relate them to that. He also reflected on the fact that light, at one time thought to be strictly a wave phenomenon, which has both wave and particle characteristics. So he came up with an equation that predicts that all moving particles have wave characteristics. He also explained why it's impossible to notice the wavelengths of a fast-moving car. A wavelength is far too small to be seen or detected. So this experiment was proven that electrons and other moving particles do indeed have wave characteristics. He knew that if an electron has wave-like motion and is restricted to circular orbits of fixed radius, only certain wavelengths and energies are generally possible. This was Broglie's equation that he came up with to back up his claim. The first part means wavelength in meters, beginning of the equation. V equals the velocity in meters/seconds. M is the mass in kilograms, and H is Planck's constant in J/C.